Hello, I'm Eric Snodgrass, and thank you for watching this in-depth ag forecast brought to you by Nutrien Ag Solutions. Well, this afternoon, as I was waiting for the brand new European long-range forecast to come out, I was taking a look at temperatures across the country. Following a day of near triple-digit heat in the midsection of the United States, we now see that the hottest conditions have moved farther to the south and pushed into parts of the southeast as well. And this has been an area that throughout much of the summer has really resisted seeing such high heat. As this pattern evolves over the coming days, we're going to see quite a bit of cooler air coming out of the Hudson Bay to the Great Lakes and really bring that cooler air across much of the eastern half of the country. I'm going to get to that in a few moments here. But what I was curious about when looking at this pattern, which when you get a good look at all of the different advisories and warnings out there, we still have a substantial part of the country with heat advisories. That's in this color. You can also see it down here. We have excessive heat warnings here and all the way down into the lower Mississippi River Valley along the Gulf Coast. And there is an active southwest monsoon. There's a lot of air quality issues, not only here, but in parts of the upper Midwest, and we're still dealing with some severe weather across the east. So when I was seeing this pattern and starting to see the warmth shift a bit farther to the east, it just got me thinking about some bigger picture things and how they could possibly be changing. Because when I look back over the much of the month of July, this would be July 1st through through July 28th. What I see here is a quite unique temperature pattern. In other words, when I look back over the last 30 years, it's quite rare to see the temperature pattern look like this through the month of July. In fact, I can't really find a solid analog for it. But it's been quite cool in the midsection of the country compared to normal and up until just recently. Same thing for the south and also into the northeast. And this split almost west to east in terms of temperatures here just got me thinking about a few things. And the first thing was this. I went out and I found for this eastern side of the United States, those summers, June and July, that were really hot. And I listed off the years that are right down here. And I want to know what the jet stream was doing. Okay, so there was a ridge here and another ridge sitting somewhere in here. So the flow of the jet stream kind of goes around it, dips into the Pacific Northwest, and then runs up over the ridge here that's kind of almost the border of Ontario and Quebec. And in that particular scenario, we got very hot and very dry and a lot of high pressure over parts of the eastern side of the United States. All right, so that is what I need to compare against. Where have we been so far this year in July? Well, it's almost as though you've just backed the entire pattern up, about 1,500 miles. So we have a ridge sitting here over the month of July and another one that sat right here over central Canada. So the flows come over, that trough is here, it then runs up into a large ridge into this area. And we've kind of left lower heights and at times lower pressure in through this particular region. And what this has done is it's given us that temperature pattern that we just recently saw, but it has also given us a very unique precipitation signature. And I'm going to talk more about that in a second, because I went down to the surface now and looked at the air pressure. And so far in the month of July, we've had higher atmospheric pressure that's extended from the Canadian Prairie through Quebec, and also the Bermuda high has been quite strong as well. And what this has done at times is given us winds that have done something like this. So they kind of come around this high and they keep coming around, opening that Gulf of Mexico. So we continually supply a lot of moisture from the Gulf of Mexico. And there's something key in that this year, that this Bermuda high has been so strong and almost stationary. That's given us the temperature and precipitation we've seen. Because when I look in the soil next as to understand what's going on, this would be the July 29th top 16 inches or 40 centimeters of soil moisture. And there's just a couple things I want to think about here. A lot of storms across the south. All right, we've had tucked away on that boundary right in through here some heavy rain throughout the month of July. Interestingly enough, through parts of the Ohio Valley over to the Appalachian Mountains, there's a corridor in through here from Kentucky through Virginia and then up to Pennsylvania and Ohio, that area that has been quite dry. It's missed out on a lot of the rainfall. And then you also notice the issues we've been discussing here in the northern plains, upper Midwest. But I've been in this area a lot lately. In fact, I've driven this direction. I've driven from Indy to St. Louis up to Des Moines over to Omaha, where I am right now. And I've also driven all the way across South Dakota right here on I-90, getting a good look at things as well. So I've got some perspective on this crop, and I just want to share with you, I think, what I've learned so far. Because I've been talking with a lot of growers, and some of the folks in these areas that are really dry, for example, I've been talking to a lot of folks right here in and around Des Moines where that soil moisture value is so low. They kept talking about how many times throughout July when storms have been missing them, they've still been able to get dew in the morning. And I know that's critical for a corn and soybean crop. And so I went back and I looked at something here. Now, in 2012, there were pockets in Iowa where I just was that have been, just absolutely scorched. And so I went back and looked at the 1st of July through the 26th at relative humidity. All right, so now we're trying to see how much moisture is in the air that we can get out in multiple ways. Yeah, it can rain, but you can also get those morning dews. And I noticed that the highest values were, of course, down here in the southeast, but we were expansive in a dry region right here. Now, watch this. This is the same time period, but I'm going to switch it to 2021. And what you notice here is we have really had no trouble keeping that Gulf moisture open and getting pretty far to the north. Where it's missed has been this region in through here. And of course, the western United States has been so exceptionally dry up until the stronger monsoonal flow has come in. I think there's a key there. I think that moisture and the dew we've been getting in the morning has helped sustain the crop. We'll have to look more into that as time goes on. But now let's just turn our attention to precipitation. This is now looking again at that same time period, the 1st of July through the 28th, and we got the ranks. And we have seen at times a very stormy pattern across much of the United States. The drier places have been here in the Pacific Northwest, the Red River Valley of the North. And I just want to make note, you see this region down here in southern Wisconsin, which had been so dry throughout the year. They got some big storms here yesterday. I'm going to show you that in a minute. But you notice the Appalachian Mountain region, that's been dry as well. So from there, let's just go look at those storms. The last 72 hours of total accumulated precip. Strong southwestern monsoon, open daily convection stretching across the south, a drier pocket in between, and then if you just take a look, those storms that came out of this part of Minnesota getting into Ontario, as they went last night through Wisconsin, they did have more of a westward trajectory and brought more rain down to some very dry locations. And now we're watching where those storms are going today because they have a history of being kind of nasty. A lot of hail in some of these storms. Take a look at the hail swaths that we had measured here coming out of Minnesota into Wisconsin. And we've had some pockets of some smaller hail out of a lot of these other storms here as well. But they also produced some strong straight line winds. And if you look back on the storm reports yesterday, we're at about 270 reports, and the storm says they came through Wisconsin toward Chicago to northern Indiana, southern Michigan last night. It did produce quite a bit of nasty weather. So where are they now? Let's get to that. So this is a radar animation from yesterday, and it goes up till just a little bit ago. We're going to go and let this play through and reset, but here's those storms firing again on that boundary today where we're watching. But that's the squall line that went racing through southern Wisconsin, northern Illinois, and that is its position later today. So watch the storms refire on the outflow boundary right there. There's a front, and we're seeing some of these storms produce some pretty nasty conditions. Behind it, take a look at this. Latest satellite imagery, so this is valid almost about the time I'm recording this. And you can see the smoke from the wildfires coming out of Washington State and Alberta, British Columbia, and it's coming around and getting pulled in behind this. So very, very poor air quality here in parts of Minnesota and Wisconsin. So we just go back to this morning. I just love watching these things bubble right here, just at sunrise. And then those storms pushed a little bit farther to the south. You can see them sitting on the boundary there, on the smoke behind it. And as time goes on, they're firing again right here on this line. But it appears, as I get to the end, that some of these storms have kind of just popped out. I don't see any deep convection still underneath them. But the southwestern monsoon's going again, and that's going to be the main thing we're going to be watching, that southwestern monsoon and the progression of this front. That's a major piece of this upcoming flow. Now, I would like to show you that smoke. So this is just a forecast here through the 31st. So it started over there. Here is throughout the day today, and then as we get into tomorrow, you're going to really see the shape and position of the jet stream by just watching the smoke kind of trace through it. And that's what I want to talk about, all right? So in this forecast, I think most of the story is going to be had right here. This is the 12Z European, and we're looking at jet stream level winds, and we're just going to follow the flow. So there's the large ridge. There's the trough that's between the Hudson Bay and New England, and I want you to keep an eye on this trough right here. Because as we play through Thursday, into Friday, and Saturday, we now see that this is cut off. There's a very sharp ridge that develops here along the spine of the Rockies going clear up to Alaska. And the downstream trough is broadening and deepening and heading farther to the south, such that by the time we get into Monday of next week, that ridge right in through there is a high amplitude, but it is a very short ridge in terms of its wavelength. And as a result, downstream, the front sags to the south. In fact, that's why we have jet stream level winds, because of strong low-level temperature gradients. And inside of this, we got some cooler air coming in. Now, how long does it last? Well, it's going to last as long as we keep the North Pacific into the Gulf of Alaska blocked up. So here I am to next Wednesday. And what do I mean? Well, you see the ridge going over it and the trough cut off underneath it? That's a high over low pattern. It's just going to fling the strongest winds way up here into Canada and then let the residual of that, the weaker stuff, come down and dives into a trough over the eastern part of the United States. So much of next week is going to be cool if you're in the eastern half of the United States. If I just keep playing this, after that block in there tries to start to move, I'm all the way up to the 6th of August here, just keep going. Another reinforcing trough cuts down. And that's really changed our temperature patterns. And I'm going to talk to you about that in just a few seconds over the next 10 days. But let's zoom out here and just take a look at what we should expect. I have found that the WPC's precipitation forecast, and again, this is a blend of National Weather Service, human forecasts plus the models, they have really honed in on this pattern quite well. And what they've got for us here is this. The frontal boundary is moving south, scattered storms today. It's going to set up on Friday to possibly bring in more rain right into this area. I'll show you in detail in a few moments. Then the frontal boundary stalls out once it gets down here pretty far to the south, so widespread 1/2 inch to 1.5 inches of rainfall as that boundary slows down. And it's all curling up into a low. That's first low that's coming through here, and a second bigger low that goes around the Hudson Bay once that trough establishes itself. Strong southwestern monsoon. Now, we got all the places that we expect the rain. Now we start to see those regions where things start to miss out. And you notice that it's these areas in through here that are going to be drier in this same pattern. More details in a few moments. First, how about the European Model 12Z? So to see this all play out, let's now get through Thursday into Friday morning. And this is Friday midday and Friday evening. So what I'm going to be watching most carefully, in addition to the southwest monsoon, is the position of this front, see it right there, and how it interacts right into this area with some of the destabilized air that's there and also the moisture that's in place there. Because going from Friday evening into Saturday morning, the European model has been very consistent all week with returning good rain to this area that then spreads into northern Missouri and into western Illinois, and then slides down that frontal boundary. It's still sitting right there over to Kentucky. That's been a consistent theme all week long. Now, we still have some scattered showers that are in the trough that is sitting over the Great Lakes in Ontario. As we play this forward, let's just get out to Sunday evening. Now that frontal boundary is much farther to the south. So we're clearing this out with higher pressure and cooler weather after that, and that pushes the frontal boundary farther to the south, such that by Monday morning, afternoon, and evening, now we've got that boundary pretty far to the south here. Okay, now watch this. Getting into next week, that's Tuesday, going into next Wednesday, all the way out to next Thursday. High pressure's in control here, and that boundary slides pretty far to the south. It's just, where does the tail of it end up as we put the flow around this bigger high pressure system that's going to sit right here? We could get more scattered storms into the midsection of the country, and little weak waves move through Canada. So there's going to be scattered storm chances there as well, and that's all because the jet stream's so blocked up over the over the Gulf of Alaska. So if we stitch it all together and look at anomalies, this would be the 12Z European. So you can see the dry regions versus the wet, and it's a very clear picture as to where that frontal boundary is going to go and the regions that are going to be seeing the additional precipitation. What I'd like to do, though, is compare it to the 12Z GFS, just to get some multi-model comparison here. And overall, I like this agreement. Where the models have struggled all summer long is down here, from Mississippi to South Carolina. And once again, the GFS doesn't have the same resolution, I think, to pick up on the storms that are going to be down there, and therefore it's biased way too dry. All right. Now, speaking about the Southeast, let's go back and talk about hurricane activity because the National Hurricane Center is not predicting anything over the next 5 days. And there's a few reasons for this, all right? First, I was just taking a look at some of the convection coming off of Africa. So this is just some satellite data. And we do see, and we would expect this time of year to get storms running off of the Sahel. That's the little boundary region between the rainforest and the Sahara Desert. But these storms that have come off of here have really struggled to develop. And I think there's a few reasons for that. There's been some upper level suppression, but there's also been quite a bit of dust in the air there. And that dry, dusty air is really inhibiting some of the growth of these tropical thunderstorms and preventing them from becoming tropical cyclones and hurricanes. But as we look out there, I'm just going to zoom in a little bit and show you a couple things. Ocean temperatures first, and we're going to finish with these two, by the way. A couple of things I want to point out. We've seen some stronger trade winds at times here, and that tends to weaken the wind shear in this area. And that is something that hurricanes need to have happen in order to develop. They need low wind shear environments. But the ocean temperatures are quite warm in this area. What will be happening throughout the month of August, which naturally is a time period where we increase hurricane activity, is if that wind shear stays low, and what I mean by that is if you look from June through July, August, and September, that time of year is our lowest wind shear time. If the values like they have this year, which are shown in blue, stay below that black line right there, we would have a calmer Atlantic over which we could develop these tropical cyclones. And by the way, this is the one of two reasons why hurricane season is during this time period. Ocean temperatures are warm enough and you have low wind shear. Now, I have been paying close attention to this. This is basically the position of the MJO. And starting in August, you see this cooler colors in through here. That is going to signal a return of the MJO over to phase 1 and give us a lot of rising motion over parts of Africa. And then an effect of that, if we we'll look at the control run, we're going to possibly be seeing quite a bit more convection after we get through the first few days of August, which means expect more hurricane activity getting into August. Plus, it is climatologically accurate to say that we're going to increase that. Okay, now we got hurricanes, tropical stuff out of the way. The models do not agree on week 2. They both try to put this deeper trough in place here, but the flow after that in the GFS is weak and undefined. And because of the lack of any definition of a feature across the United States, each new model run has given us a very different outlook on Precip. And this is the latest, so we'll kind of get that zoomed out so you can see it. Overall, it's trying to continue to produce quite a bit of thunderstorm activity in through here, but it's drier south. What's interesting is when you look at what the European model is saying, so this is its flow pattern, it's got that same trough. It's got another trough here and an extension of a broader trough in this area. So the flow comes around that, ridges here right on the spine of the Rocky Mountains, and then dives into a deeper trough there. So it's only logical, given the depth of that trough compared to normal, that the European is considerably wetter in this area. But I'll just tell you something. What you've got here is going to be coming from a lot of scattered thunderstorms. And there will be a pretty well-defined line, probably right into this area, that if you're to the west of it, those scattered thunderstorms are going to be more limited than they would be to the east of it. But at this point, I don't see anything that shuts down the Gulf of Mexico, and therefore the moisture transport will be there for those scattered storms to produce their rainfall. But again, major difference, especially across the south, between the two models. And the European has done a much better job in the south at picking up on the rainfall. Now let's talk temperatures as we get toward the end of this video. Today's highs, we've already kind of seen what those are going to look like, but let's get into tomorrow. Look at the cooler air coming in behind that front on Friday, while the ridge really pushes here through the Columbia Basin and up along British Columbia, eventually into Alaska. We shove that warmer air farther to the south on Friday. On Saturday, even farther. And then getting into Sunday, now the front is really far to the south, and we're much cooler across a broad sector here in the United States. Now watch this, going from there into Monday, Tuesday, and Wednesday. That cooler air is just locked into place. And while we attempt to return to upper 80s and lower 90s here in the the northern plains of the United States, I think more of this heat's going to be confined farther to the west. Because as I look out there at the brand new data that was just released a few minutes ago, we can see that the day 5 through day 10 time period maybe has that ridge much more amplified, heading like this. And east of the Rocky Mountains, it's going to be hard-pressed to find sustained well above average temperatures. In fact, we're going to see some temperatures that might be 3 to 8 degrees cooler than normal for a stretch here as we work our way into the month of August. Now, from there on out, we do see in some of the models with that weaker flow, so for example, in the GFS, it tries to bring in some warmth as we get toward the end of the first week of August. But as you can imagine, the European does not share the same warmth in this area as the GFS does. So I'm showing you the GFS because it has been the most aggressive on returning heat to parts of the central plains of the United States. Now, from this point, as we look longer range, I want to first talk about momentum. You see, throughout July, the atmospheric momentum has really built up, and it's lately fallen back off. We've lost a lot of momentum right here, about 35 to 40 degrees north. But our jet stream in this area has not really had much momentum in it for a while. The highest momentum values have been right here just north of the equator, and then down here south of the equator. So my point behind telling you this is that the jet stream ability to get blocked up and stuck is relatively high. So where would the movement come from? I think it could come from the MJO. Now the MJO throughout the month of July has moved out of the Indian Ocean over Australia, now is in the Pacific, and is about to come and do a reset back over Africa. And we just talked about this. Through the next 15 days, the models are suggesting it moves back over the Indian Ocean. And then as we get into mid-August, it could be somewhere in here in phase 3. Now, thinking about that, getting back into phase 3 or even phase 4, I want to show you what that typically means. This is what the jet stream level pattern in August looks like. It tends to be trough features here, kind of coming off of Russia into the Bering Sea and Alaska, troughs off of the west coast, but broader ridging in place here and here as well. But notice the troughing south. Now, why I bring that up is it's going to look different, but it's this the same view, a 500 millibar height anomaly map for what we've had so far this month. Now, there's the trough coming toward Alaska, and it's been extending here as well. There's the ridge, and the ridge opening up here with lower heights in place there. And although the color scheme is different, the pattern seems to go back on a repeat of what we saw in July. That's just part of what I think we're going to be seeing for this upcoming forecast. And because we don't see anything shutting down the Gulf of Mexico from August 7th or 8th through July 9th, we see that 30 such day time period as open Gulf, lots of moisture extending into the midsection of the United States where we talked about earlier the higher relative humidities being in place, troughing maybe in this area with the ridge running over the top of it, which gives us a stormy pattern. And the models are taking that moisture and just consistently making it look wet in the month of August. In terms of temperatures, it's all the new data here. Warm too. That jet stream is displaced to the north. But the thing that we just haven't been able to shake is the positions way over here. That's the Bermuda High. So nothing shutting down that Gulf moisture. And the models just take it in, and they have to make it precipitate to stay, to obey continuity, to just keep the in coming out, okay? Now, how long does that last? Remember I said we're going to talk about those ocean temperatures. We've been keeping an eye on the cooler water here beneath the ocean surface. So this is the Pacific, the sea surface, right? And on this side over here is South America, and on this side is Australia. This is down. There's been cooler water in this area that's beginning to surface, and that is the La Nina we've been discussing. And what's interesting is, just to show you again, that September, October, November timeframe would favor a drier harvest because of that. The one wild card is going to be tropical cyclones, and I'll have to just keep an eye on those because our forecasting window on those is generally less than about 10 days. So I just wanted to show you all the things I'm thinking about, and we'll watch it over the weekend. I'll tell you again about it on Monday. Appreciate your attention. Thank you.